Okay, so here's our last video on our first unit of measurement, and we're going to be looking at converting between the imperial and the metric system. So as we know, in the Canadian system, we use the metric or SI system. Well, in the US, they use the imperial system. And as, oops, that's bad. And as the US is our biggest trading partner, we need to be able to convert to their units. They will not bend to our units. Down in the US, they actually do in science use the metric system, but not in their everyday life. So as before, it's a good idea to have an idea of the reference for both, and then which ones match up with which. So here's some examples of the common units in each system and what they, again in bunny ears, match. On the right, we have 3 exact conversions and we have the other approximate conversions. And what we want to do as best as possible use exact. So what we want to do today is just work through some few examples of changing between. Again, if you in your work later on have any contact with the US, then you're going to find that you're going to have to be able to do this. Okay, let's do the first one. We want to convert 156 meters to inches. So first of all, a meter is the distance to a doorknob, and that is much bigger than an inch, the width of your 2 fingers. One of the things we want to recognize is that these units do not match. Meters match yards or feet, inches matches centimeters and millimeters. So what we're going to have to do is we're going to have to go through an initial measurement and get to where we want to do. Now, given that we're converting between here, the unit line approach is not very useful. We're going to have to use a unit analysis. Remember, unit analysis, start, finish, and the conversion factors in between. Our start is going to have 156 meters, and somewhere along the line, I need to get rid of those, and I need to end up with inches. So again, meters match yards. We do have an exact conversion between yards and meters, and we have 1 yard is slightly smaller than 1 meter. Now we do have an exact conversion from feet to yards, and 1 yard is 3 feet. And we do have an exact conversion from feet to inches. We started off with meters. We got rid of those. We could convert nicely to yards, and then to feet, and finally to inches. And when we do that calculation, we are left with 5,949.15 inches. A lot. So again, we have 156 of these big units. Therefore, we're going to have a lot more of the smaller units. Okay, let's do another one. Convert 4.5 centimeters to feet. Now here's actually a nice one because on our notes above, centimeters, well, goes to inches, and then inches matches to feet. So our unit analysis approach would look like, here's our start. We have an exact conversion from inch to centimeter. And again, we want to get rid of the centimeter, so it's on the bottom. 1 inch is 2.54 centimeters, and we want to end up with feet, so I need to get rid of inches, and we do have a nice conversion there. So again, a centimeter is a small measurement, feet are bigger, and we can do it this way. And when we get rid of the centimeters, when we get rid of the inches, all that we're left with is feet. When we do this calculation, we ended up with 0.15 feet. So this way turns out to be a bit of a long way. If you look in your exact conversion, we do see an exact conversion from feet to centimeters. It's 1 to 30.48. So we could also do this in another way by going 4.5 centimeters times that exact conversion to 30.48. And again, centimeters cancel out. We're left with feet, and either way, you get the exact answer. So notice the similar approach, just different conversion factors. Well, let's go to example 3. Example 3 is a bit different. Notice in our conversions, we have linear conversions, centimeters to whatever, to inches, centimeters to millimeters. Here is an example of something we do not have an exact conversion from. So notice the measurements, square centimeters and square inches. On our sheet, we have no exact conversion. Having said that, we could go ahead and do a unit analysis approach because we do have centimeters to inches. And if we treat centimeters squared as like the exponential definition, centimeter times centimeter, well, what we could do is we could look at 46 centimeters squared as something like this. And when we want to get rid of those, both of those centimeters, well, we know that there's a relationship between centimeter and inch. And it's 1 inch is 2.54 centimeters. And if we looked at this approach, which is a unit analysis approach, well, one of those centimeters cancels out one of those centimeters. Now, if we looked at this, we do have an inch thing that we want to end up with, but we also have a centimeter on the top, another centimeter on the top. And if we want to get rid of them using a unit analysis approach, all we have to do is, well, get rid of the centimeter again using our exact relationship that we know. And when we do this unit analysis approach, we get rid of both of those centimeters and we're left with inch times inch, which is inch squared. And when we do this calculation, we end up with 7.13 square inches. Okay, so there's unit analysis approach. There might be a better approach. If we considered 46 square centimeters to be the area of a rectangle, well, what we can do is come up with any picture that has, any rectangle that has an area of 46 square centimeters. And the simplest one I know is a rectangle that has a length and a width like this. So here's my 2 times 23 is 46 and centimeters squared. What we can then do is we can convert each of these dimensions to inches and then do the area calculation to get our inches squared. So it would look something like, okay, I'm going to call my L the longest one. We're going to have 23 centimeters, and really what I want to know is, well, how many inches is that? So we're going to multiply by our conversion, and they're going to cancel out. And what we're going to end up with is 9.0551 inches. And when you're doing these kind of calculations, intermediate calculations always go to 4 decimal places. Similarly with the width is 2 centimeters times 1 inch per 2.54 centimeters. These centimeters cancel out, and our length is 0.7874 inches. Again, 4 decimal places for intermediate. And when we then go ahead and figure out the area of our rectangle, by multiplying these two things together, we get 7.13 square inches. Okay, last example. MPH, first of all, I want to point out MPH is the recognized name for miles per hour. So what we want to do is convert 70 miles per hour to kilometers per hour and meters per second. The first one's a good one because when Americans come across the border and they see the speed limits, of course, they're in kilometers per hour. Lucky for them, there's a separate gauge on their speedometer that will do that. So what we want to do in this one is, if we're going to start off with 70 miles per 1 hour, well, we want to go to kilometers per hour, so we want to keep the hours. We want to get rid of the miles. And if we want to get rid of the miles using unit conversion, then we're going to have a miles thing on the bottom and a kilometer thing on the top. And we have an approximate conversion for that, 1.609 kilometers for every mile. And when we cancel out the unit we want to get rid of, what we're left with is kilometers on the top and hours on the bottom, and that's what we want. So this one's a little bit different in that we have 2 units, distance and time, and in our first example we want to change one of them and keep the other one. And when we go ahead and do that, we end up with 112.63 kilometers per hour. Now that we've done this, we can convert this to meters per second. So notice in this example right here, 112.63 kilometers per hour, we want to get rid of both of these units. And it really doesn't matter which one you get rid of first. So I'm going to get rid of the kilometers first, then I'm going to get rid of the hours. Again, we know an exact relationship between kilometers and meters. It's 1,000 to 1. And what this does is it gets rid of kilometers and leaves us with meters. And now I need to get rid of hours. So again, with our unit analysis approach, if we have hours on the bottom, as we do, I need to have a relationship where hours are on top and seconds are on the bottom. And as you know, there's 60 minutes in an hour and 60 seconds in a minute. Therefore, in 1 hour, we have 3,600 seconds. Again, with our unit analysis approach, we end up with hour, cancels out hour, and what we're left over with is meters on the top, seconds on the bottom. That's what I want. And now all I have to do is go ahead, plug those all in my handy-dandy calculator, and I end up with, well, 70 miles an hour is 112.63 kilometers per hour, which is 31.29 meters every second.